We are going to learn about cotangent today. This is our fourth graph. The good news about this one, this is going to be a really short lesson because you pretty much already know how to graph cotangent. If we've done sine and cosine and we've done tangent, then it's going to be super simple to do this one. So let's start with the parent function. You're going to notice here that we have just a traditional A1 and B1, right? So the good news is we're back to starting at 0 again. So we can go ahead for the parent function. I'm going to go ahead, since I know this whole period is pi, 0 plus pi is pi. And I broke it down into half of pi is half pi, and then half of that is pi over 4. So I knew I was counting by fours. This is almost like a quarter, a dollar, right? 4 quarters and a dollar. That's pretty easy. All right, I take my first mark, put an asymptote, and I take my last mark and put an asymptote, just like tangent. Here we're going to put a middle point, but this is where it's different. We go up on the left and down on the right for cotangent. Right? Tangent was backwards. We kind of go down on the left side and up to the right. Cotangent's natural function is to start up at the top on the left and go down to the right. That's good. That's a natural cotangent. If it had been negative, then it would flip over, and negative cotangent looks just like tangent does. However, if you notice that here we shifted over a little bit. Tangent goes right through the origin. If you go back and look at tangent, right, it kind of goes over here. It's up, down, and like this, right? Here we're going to start at 0, just like sine and cosine, and we go forward to the right, and we add our increments this way. I could also do the increment. We'll do this in the next example. Pi divided by 4 is 1/4 pi, right? So 1/4, 2/4, 3/4, and 4/4 is another way of doing this. I didn't really work that out because it was pretty easy to kind of see that pi divided up into 4 parts would be just like this, right? So this is your basic cotangent function. We have an a value of 1 that brings us up to -1 or to +1 and down to -1 here, and everything else stays pretty much like it did with tangent. Let's look at another example and kind of take it all out and look at the phase shift and vertical shift and all those things too. All right. So now we have a few things. We have A that's going to be equal to 2. We have B is 3. We have our pi for H and -1 for K. Let's find out our period, our vertical shift, and our phase shift to start with. These are always good ideas to write this stuff down, because if you make a mess in the graph somewhere, I can always go back here and at least give you some credit for getting out the right values in your scratch work. So here we see our basic functions. We have period, which is pi divided by 3, pi over B. Phase shift happens to also be pi divided by 3, right? So it's the same, just coincidence there. We are going to do a couple things here. We're going to go ahead and let me move this up. We're going to take our beginning and we're going to let that become, just like sine and cosine, we're going to let the beginning be the phase shift, right? So you can see it right here, right? The phase shift, we're going to go ahead, we're going to mark that on my horizontal axis. My phase shift was positive, so I kind of went ahead and put down my y-axis. My increment, if you remember back from sine and cosine, this is going to be my period divided by 4. We're going to do the exact same thing again. So take that, pi over 3 divided by 4, which is 4 over 1. Flip that over, you're going to get pi over 12 as my increment, right? So that would mean that I'm going to add pi over 12 to this value to get here, then add it again, then add it again, then add it again. So we'll do the first mark just to kind of get it all into common denominators. We'll take pi over 3 plus pi over 12, multiply top and bottom by 4, so you get 4 pi plus 1, and you get 5 pi over 12. So my first mark is going to be a 5 pi over 12 here. Now, as you go along, typically if I know that it reduces, I might write that value down below it and then reduce it up top. This one doesn't need to be reduced, so we're just going to leave it alone. We're going to add 5 plus 1/12 again. 5 plus 1 is just 6 pi over 12, but that reduces to 1/2. And then 6 plus 1 is 7 pi over 12. And of course, 7 plus 1 is going to be 8 pi over 12. These are even, so I knew they were going to reduce. I wrote them down here so you could see them. In practice, I probably wouldn't do this. I can probably reduce 6 over 12 is pi over 2. But I'm going to write the reduced fractions here. Once I've got my x-axis labeled, I've got all the hard work done, right? So we're going to come in, we're going to drop our asymptotes in. I'm going to go back in, I'm going to label my y-axis values. I tend to do this actually first. I put the midpoint in, midline in, wherever my midpoint's going to be, right? My vertical shift. Then I go up and down with A, right? A is 2 here, so we added 2, we subtract it to. That's typically what I do first. And then I'll come in and fix the x-axis and then put my midpoint in and then kind of go up to the left, put a point in here where your values meet, and then one over here where the values meet again. And then we have our cotangent function. I hope this really makes a lot more sense. If you've gotten tangent down or had a lot of experience with tangent, kind of using this and knowing the pattern that it takes is the only new thing, right? Cotangent goes from the top left down to the bottom right. Tangent would be up like this. Of course, it's a different shift as well. But if you remember the beginning and the increment, just like we do with sine and cosine, then we can kind of bank on what we've done in the past to really make this a much easier task to handle. And that's it. I'm really not going to bore you with more examples about cotangent because if you can get this one, this is the same. I'm just going to change the values at the bottom. And working with twelfths and halves and thirds, I mean, there's lots of fractions too. So take this example, work with it, use this as a model for doing all of your other ones. If you got any questions, please send them my way, and I'll do my best to get back to you as soon as I can.